about wave superposition. So hopefully at this point you know what a wave is, how waves behave, how we describe waves, and what we're trying to do in this video is explain to you the principle of superposition, wave superposition. The idea is that if we have two waves moving in the same medium, say that we have one wave moving to the right, going from the left to the right, and then at the same time we send a wave from the right to the left, what's going to happen? How is the medium going to behave when it has two waves moving at the same time? So to answer this question, let's take a look at a simulation here that I have. So we're going to start with two identical pulses, and we're going to send one from the left, one from the right. As you can see there, both have positive displacement. And what the third graph shows is what the actual medium is going to do. If this is a string, two pulses moving in a string, this is actually showing you the shape of the string at different times. So as time goes on, you see the two pulses are getting together, coming together, and of course the interesting thing is going to be when the two pulses are overlapping, that is when they're occupying the same portion of the string. So let's play the movie and see what happens. The two pulses, after the moment when they're overlapping, they continue to move in the same directions that they were moving before with the same shape. So let's stop here for a second. Let's go back a little bit to the moment when they're about to, when the front of each pulse is starting to overlap with the other pulse. So at this moment we can still recognize the shape of each pulse, but as they continue to move towards each other, we see that the shapes of each individual pulse is not recognizable anymore. And at the moment when the two pulses, the crest of each pulse is actually at the same location as the other one, we see that the resulting wave that we have in this string has an amplitude that is twice the amplitude of each individual pulse. So this is a characteristic of the behavior of waves in a medium. That is, that the resulting displacement in the medium is the sum of the displacement of each individual wave that is traveling through that medium. At the locations where the two pulses or the waves are overlapping, we can expect this behavior. As time goes on, again, as we said before, we can again recognize the two pulses when they're not overlapping. Each pulse can be recognized, but at the moment when they are overlapping, we see that the resulting pulse is the sum of each individual pulse. Now let's take a look at perhaps an even more interesting situation, which is when the two pulses have opposite displacement. So we have one pulse with positive displacement, an amplitude of 20, and the other one with a displacement of minus 20. And again, when the two pulses start to overlap, that's when things get interesting. Right about at this moment, when the two pulses are starting to move on to the same location or the same region of the string. So the difference with the previous case is obviously that the displacement of the two pulses is opposite. One is positive, the other one is negative. So in the previous example, at the moment when the two pulses are overlapping, the displacement became twice the displacement of each pulse. At this point, when the two pulses, notice that the crest or the maximum or minimum of each individual pulse is reaching 5, x equals 5. At the moment when they are exactly at x equals 5, maybe a little behind, wait, no, a little forward, right about there, we see that the two pulses are actually canceling each other out, that the displacement of the string at this moment is basically 0. We say that the two pulses are destructively interfering with each other. As we continue to play this, we see that the two pulses bounce back and they continue to move exactly the same way they were moving before. So it's almost as if each pulse does not care about the other one. The pulses do not seem to interfere with each other, and the resulting displacement of the medium is simply the algebraic sum of the displacement of each pulse. When we add the positive quantity, the positive displacement with the negative displacement, we can get 0, which is the case when the two pulses are exactly on top of each other. So this is illustrating the basic principle of superposition that happens for waves and for many other concepts and situations in physics. The principle of superposition says that the resulting, in this case for waves, the resulting displacement of a wave is the sum, the algebraic sum of the displacement produced by each one of the individual waves that are traveling in the medium.